We will try to read about memory elements. Hey, my voice who has kept down memory elements. Okay. Now, hold on. So this memory elements, last class I was telling you about raw PLDs. Yes. So now that time somebody has questioned me if the ROM is itself is a memory. Okay, somebody has questioned. I don't remember completely who has done that. So if ROM is a memory and we are writing in that, how the ROM will be like, how we will write into that. Then I told it's an electrical process or it's an electronic and electrical circuit where we will try to input the information inside that through the what? Through the circuits only, making a switch, then afterwards how to send the, how to write the, write the information into that. But anyway, that is a VLSI designing, so I'm not going to touch into that. But what is ROM made up of? That is what today's class I'm going to discuss. A ROM, I'm saying that it is a memory, but memory means it should be maintained by something, right? So memory cells will be there. And now in order to make that cells, which we will call that elements or cells. Okay, that's the word used. So in order to maintain this one, we try to use latches. The next level is flip-flops. Right? Either this or this. This is the upgraded version. Flip-flops are the upgraded version. So many people have information about that, but still, please try to understand. I am going to introduce what is the latch. Okay, latch. I will say latch, not latches. And flip-flop. Singular. What is the latch and what is the flip-flop and how they contribute to the memory cells and how these are linked up with this. But these are combinational circuits. But I am talking about memory. So combination and memory together makes sequential. Now carefully understand. These are combinational. These are memory elements. This plus this will give you this. Sequential. Now new words have been introduced called sequential and memory elements. Right. Now if you see carefully, sequential means it follows a sequence. Right. So it follows a sequence with respect to what? With respect to, always remember, it is instant process. That means it follows time bounded. So sequential circuits are time dependent. So time, every instant of time changes, what will be the output, right? And now if at all time t plus 1 is there and time t is there, that means last instant and next instant I should have some memory to remember. So that will be contributed by this, right? Apart from that, support will come from the combinational circuit also. So in fact, sequential circuit is nothing but we have a combinational circuit, then we will have some memory elements, they will also act as inputs, right? So we will have a feedback paths, then we can have outputs. That means if you can check the inputs, combinational circuits, then directly you can take the output, otherwise you can take a feedback, take the past instances, again do some operation on that and then give the output. If you can see, don't you think it's a feedback process? Yes or not?
Yes, ma'am.
Yes. So in the feedback process, if at all you take a normal gates and tell its operation, where we have done in the combinational circuit, we have a multiplexer. So we have that time inputs are there and then output are ready-madely done. But we don't have a past of that. So here, this particular one are that time instant. We don't have memory there. Those are combinational. But if I attach for that combination some memory, then it can have the capability to work for past things also. So that is called memory feedback, right? So this diagram seems to be complex. It's very easy, I'll put it. These memory elements are made up of this. So once we understand this particular topic, it's very easy to incorporate here. Design is very simple. Yes. So how many of you have any idea on the latch? This word is familiar, latch. Is this clear? This one is clear. I will erase it. Yes. answer. So I'll do that. Okay, how many of you know the word called latch? Latch. In analog circuits, there are latches. Okay, anyway, I will not waste much time in that. So latch is nothing but a combination of two gates, right? But the combination will be very specific, right? It is interconnected gates, and especially they will use in universal gates. Carefully understand. A combination of two interconnected gates, universal gates, is nothing but a latch. Then you should be understanding that the latch do have some inputs. Yes, they have inputs, right? They should be giving some outputs. Yes, they will give outputs. That means it will be, right, a latch. But inside they are interconnected. So now you can understand, you have input 1, you have input 2, right? I have output 1, I have output 2, right? But inside it is interconnected. So that means the feedback concept which is reflected in the sequential circuit is actually coming from the latch. So a latch is nothing but a simple feedback circuit, right? Which are having universal gates and then which gives outputs, right? Which gives outputs always in the complemented form. That means one output is two outputs. So these two are complement of each other always, right? These are the minimum specifications whenever we design a latch. That is what called a latch, right? So I'll take up an example and then explain you how a latch works, right? This is general meaning of a latch. Okay, if you are having any doubts, please interrupt me. Okay, so I will take simple universal gates, NAND and NOR as usual. So I'll start with NOR. Gate 1, gate 2, right? And now as per the rule, I am first making the feedback. It has its own input, it has its own input, right? So gate 1 and gate 2. Right. So I am giving some variables. Remember this S, R and all namesake. Okay. So now I am first introducing the very foremost developed latch which has two inputs. Basically they have fixed the variables S and R. Right. Gate number 1, gate number 2. And Q and Q bar always represents the outputs of the latch. Now please try to understand. Is there any doubt in your arrangement of this? We are not analyzing this right now. First, understand the concept. Is the circuit clear? Very easy. Two NOR gates are there. This is connected to this. This is connected to this, or this is connected. You can just clearly see node. A node is made. Means a feedback concept is already introduced. Is this clear? Feedback also. And what is this? This is direct input coming separately from the source. And these are outputs which I am collecting. Is that correct? Easy? Is that fine or not?
Yes, ma'am.
Yes,
Okay.
ma'am.
Now
Yes,
hold on.
ma'am.
Now I will ask a very basic question. Now as of now, for me this is not a memory. For me these are two gates. Is that correct? Two gates are there and two inputs are there, two outputs are there. Only issue is outputs are complement to each other. That's what they claim. Fine, no problem. Right. Now, what is the actual definition or a NOR gate significance? If you see clearly a NOR gate truth table, if any of the input is something, the output is 0. What is that something? If at all you take a 2 input NOR gate, yes, if any of the input is 1, the output always remains 0. What does it mean? See, when we were studying combinational circuit, we never thought that way. It has two inputs. Okay, its operation is A plus B whole, to the complement. That's what we are getting. But if you see carefully, irrespective of other input, if any of the input is 1, the output remains 0. Is that correct?
Yes, ma'am.
Yes, ma'am.
That means I can also say, that means modification in the words, if a NOR gate has two signals coming, if one signal is high, it need not wait for the output next signal. Can I use that statement for a NOR gate?
Yes, ma'am.
That is one. So now your sequential circuit's main thing is that only. See, the NOR gate is such a gate which is universal, 100%. When I am teaching in truth table, I never mention this signal sort. Now I am trying to tell you why, because the NOR gate reacts to the signal like that. If any of the signal is high, irrespective of the second signal, I am talking about two input NOR gate, irrespective of the next signal, immediately the output is low. Is that correct? That statement is correct? Yes or no?
Again,
Yes, ma'am.
Yes, again I will repeat. If a NOR, two input NOR gate, okay, receives two signals, two inputs. If one of the input is high, irrespective of the second input, the output remains low. Is that kind? Fine?
yes, ma'am.
That's it.
Yes,
So
ma'am.
now,
ma'am.
in order to analyze this latch, that statement is very important. Okay, now let us start a small trick, right? I want to analyze this circuit. Now this circuit is a crisscross circuit where the two gates are coupled with each other, coupled. Okay, right? That means when I am analyzing, I will have only two things. Okay, I will put like this. S and R, I will analyze Q and Q bar. S and R is who? Is my two inputs. So that means inputs I should select and then analyze what is Q and what is Q bar. So obviously according to the notation, we exhibit that, or we feel that Q and Q bar should be complement to each other. Okay, so I will start my experiment. It's just an experiment. It's not a truth table. It's an experiment. Please try to understand. I will set the signal high and this is low. Otherwise 1 0 I will put. That's much better. Right, this is my initial setup. Okay, S is high, R is 0. Okay, now once the signal high and low goes, right? Here, what is connected here? We don't know. This output is connected here. This output is connected here. When we start the network or when we start the experimental setup, we have no clue regarding this, what exists here. Is that correct? Everybody agrees?
Yes, ma'am.
Yes, ma'am.
When we start, that means at the 0th incident, we don't know. Now, if I give the signal high and low, according to the statement what I have provided, a NOR reacts. What? If any of the input is high, immediately the output is given low. Is that correct?
Yes,
See the
ma'am.
statement. That means it will not wait for the signal, because you see, this S is set high, is high. That means 1, right? In order for the gate to react, gate number 2 to react, it need not wait for the signal what to come. Is that correct? Should I take that?
Yes, ma'am.
So that means 0 is already declared. That will be the first one. Why I went for Q bar? This 0 has come. Why? Because its input is high. That's why this 0. Now this 0 will set this, but this will go to this one, right, as per the direction, and first gate will now receive 0 0. So what will be the output? 0 0 NOR gate. It will be 1. Is that okay? Explanation. Again I will tell. See, looking at this 1 0, it is have 1 0. But find out the explanation. Please understand the explanation. I am again removing. Right? Again I am explaining one more time. If I give a signal for S 1 and for R 0, first thing to react or the first thing to come at the output is 0 here. Why? Because the second gate will react first. It need not wait for this one, because the NOR gate, irrespective of the other input, this output will be 0 as per the rule. So hence I can say first Q bar will be 0. Then this 0 will be fed here. So 0 and 0 output will be 1. right? When I am explaining and writing, you should understand how the process is taking, because it's a continuous process. It's not an instant process. It is continuously connecting time to time. Is this clear? The first row, is it clear? Everyone.
Yes, ma'am.
Yes, ma'am.
Right, because if you don't understand the statements, then there will be a big problem when we go ahead. Okay, now after this experiment, I will keep this intact, right? And only I will change this one to 0. Remaining as it is, I will maintain. Please try to understand. This one high I gave, no? I will now give low. That means I will change only one incident, right? This one as it is, I will keep it. Right now, how I will evaluate the circuit? How I will evaluate the circuit? Now, please listen carefully. When I change after this, did you see I showed an arrow mark? When I change this one, what exactly happens? What will be the situation of this particular circuit? That means the R has changed, the R remained unchanged, whereas this S has changed its level, right? That means here, what is there in your previous one? This particular one is there. So that will be remaining intact. So what will happen here? Q1. That will be as it is. This will be as it is 1. And this will be 0. Did you understand that?
Yes, ma'am.
Yes,
So
ma'am.
this is how the sequence goes. See, this is only after S will be shifted from 1 to 0. This one has come only after this incident. That means this experiment is done. Afterwards, this experiment is done. Please try to remember. There is a link. There is a link going on. Okay, so till now here, up till here, one experiment I have done. That's all. Very simple experiment. I have started with 1 and 0, and evaluated what will be the output. Then afterwards, I made one change. What will be the next change? That's all. This is what the experiment. Is that clear for everybody? I have already
Yes,
given a bar. Yes. Okay.
Yes,
Now,
ma'am.
forget this. I have now stopped my experiment. Right. So now I will start a fresh one. This is trial 1. Trial 1. Done. Right. I will start a fresh experiment. Now I'll write in green. Okay. So I will start with this. Okay. I'll start with this. This is green one is my fresh start. Trial 2. Now tell me. S is 0, R is 1. Okay. So now who will react first? The first flip-flop
Q.
immediately will have
Q.
Q is
Low.
undoubtedly low, and this low will maintain another input low here, and this is already low. Q bar is high. Is that correct?
Yes, ma'am.
Correct. This is second trial. Second trial I started. Second trial, first incident. Is that okay, everybody? If you have doubt, please tell. Now it's it. See, when the latches are being analyzed, we have to go sequence by sequence, right? It so happens like if we miss the sequence, now again we have to go back and start the trial. Is that okay? 0, 1.
Yes, ma'am.
Okay. Now after this, I want to do a small change. After 0, 1, this 0 as it is intact, and this will change to 1. I mean 0. That particular 1 is changing to 0. Now what will happen? Now what will happen? Then also give the signal. Yes.
Q
Continue.
will respond first.
0.
Q will respond first. It will be low.
Q responds first, or it is as it is, it will be,
Yes, ma'am.
right? See, when the R value returns to 0, what will happen? The outputs will not change, no? Can I see this? Can I get the same output? Even this one is returning 0.
Yes,
Can you prove it?
Same output.
Same
Why?
output.
But you tell in statement, that is more important. Same output, it returns to 0, it's same output. But please tell in statement. Somebody is telling that time. Yeah, please continue. Yeah, please tell.
Yes, ma'am.
Please,
Sir.
go ahead.
Previously, Q dash is 1, so it will go to the input of first NOR gate, and
Okay.
and as the first NOR gate receives a high input, it will respond first and Q will be low, so it will be 0 again.
Okay. So that's why it is 0. And this is already retained high. That's what you are telling. It retained high. Why? Because S has not changed its position, state, whereas R changed its state. Is that correct?
Yes, ma'am.
That's it. See, please try to analyze. See, this is very simple logic. Very simple logic. Right? Now you just see this trial and this trial. This trial also you got 0, 0. What is the output? 1, 0. This trial also you got 0, 0. What is the output? 0, 1. Did you observe how the linkage is there? This is what called a sequence. Trial 1 and trial 2 have a repetition of 0, zeros, but the outputs are different. Why? Because this is after reset is made 1. After reset is made 1 to 0. This is after this. Is that correct? Trial 2. Trial 2 is fine. Everybody understood?
Yes, ma'am.
Yeah. So this
Yes,
is what a sequence is. See, first day sequential is always confusing. All the students in my class, I remember their faces now also. Right? What is this afterwards? Simple logic gates are there. We used to enjoy in the class. What happened to the sequence after sequence? Q bar changed. First day it will be like that. Chill. Don't worry. Right? Just follow the words what I am telling. Right? Sequence after sequence. Right? Trial 1, trial 2. How it is getting changed, right? I will tell you one more incident. At trial 3, I will start fresh one. Okay, just see. Trial 3, I will keep both high. What will happen? This is fresh trial.
0, 0. Both the
Yes.
output will be low.
Yes, both the outputs are zeros. And now you see, it has totally violated the rules of Q and Q bar. Because earlier, at least, we are following Q and Q bar. They are complement with each other. If you check in any trial. But this is a total violation. Do you agree? Yes or no?
Yes, ma'am.
Yes,
So,
ma'am.
this type of things also do happen. Right? 0, 0 it is accepting. But 1, 1 it is violation. But still we have to understand. Like, okay, 1, 1 means some danger situation is going to come. Because this is only a small block. First we should be mastering this. Then I will attach some more blocks to this. Is this clear? Is this clear?
Yes, ma'am.
Okay.
Yes,
Now, yes, hold on. Now this latch has some lacunas. What is that, you know? Because S and R, whatever the inputs are with my control. That means manually we have to change, and then outputs are reacting for that. Now, if I can make a systematic arrangement of the signals to allow, please try to understand. If I make a systematic arrangement for these signals to enter into this, that means I will keep a checkpoint on them. Just like that, don't enter. Okay, please follow some rules and enter. That means I am trying to make this SR systematic entering through clock. Now the new word has come, clock. Who is this clock? Clock is just like a teacher. Right? it is telling that signals you are allowed to move inside the latch. Till that time, I will break. So it's like that. This word is familiar, but actual meaning is it is organizing or to be frank, systematically entry is done through this. Now, who is clock? Clock is nothing, not an alien. It is also a small circuit, right? But it will allow this SR first to enter this, and clock will decide at what particular incident it will enter into this. Don't you think manually, if at all I change, the signals are a little bit disturbed by entering into the gates? Can you do at a stretch? I mean, at a particular instant means at that instant can we do manually? No, no. We do get some problems of switching. Don't you understand? If at all, see, S and R, if I am manually pushing, so my two hands will not be doing at the same instant. Is that correct? So one can be slow and one can be fast. Can be. So that also can be avoided using clock. Now, who is clock? A clock is a circuit which will allow the signals into the latch at a predetermined or a particular incident. Right. So now that one is called a clock SR latch, which is nothing but flip-flop. Now, if a clock I will arrange to this latch, it becomes a flip-flop. Now, flip-flop is the higher edition or a higher version of your what? Latch. Right, very simple. Clock is nothing but a higher version of your what? Latch. So, should I draw that? Flip-flop, first one. Right, very simple. I will take the same thing. Okay, otherwise I will arrange. Right. So now, for this particular system, what we are trying to learn, I will again start with your same latch as the building block. I didn't change anything. Keep it as it is. Your gate 1, gate 2, as it is. Connected, interconnected. This is Q, Q bar. Right? These are your SR. Okay. Right. Now what I will do, I will use a gate. Right. And now this gate. Right. This gate. Why I use the AND gate? Otherwise 2 AND gates. Not 1 AND gate. First 2 AND gates. And 1. There are different varieties we will prepare. Okay, initially I will put like this. Now you see. Now you see. Till this level, it's a latch. Okay, and now this is the extra. 3 and 4 is the extra. Is that correct? 3 and 4 is the extra. And now your S and R directly they are not entering, but they are entering through this one, CLK. Who is that CLK? It is a signal which remains high. So as long as this high, this gates will react. If it becomes low, this gates, 2 gates will not react. Is that okay? Is it a gateway? You people agree? Hello?
Ma'am, please explain that CLK part.
Yes,
again.
I will write 1. Okay, if 1 is there here, which is connected to both 3 and 4, then only S and R will have a value to enter. If this becomes 0, the gate is already 3 and 4 will be done. Is that correct? See, AND gate, if one of the input is 0, means the other signal will not go. No? Are you understanding?
Yes, ma'am.
Yes,
That
ma'am.
is called, yes, this is called clock. The beauty of this is I will always maintain high. Clock is a signal which is always high. Instead of writing 1, I showed a pulse which is high. People are familiar, na? In your op-amp, you have seen this type of signals? No? It's actually a pulse to show high. Right? Just to symbolically tell it is a high, and that is called clocks. Clock, CLK means it's the acronym for clock. Right? I will not give a variable C. It is clock, CLK. CLK is nothing but a gateway, right? Which is connected through 2 AND gates where the external signals S and R are connected. Now, if you see, if the clock is high, whatever the signal comes here, it will retain there. 4 and 3 will be allowed only when the clock allows. Clock high means then only signal goes. Clock low means signal will be stopped. This is the indication. Right, so that's why this is called clocked latch. This arrangement is called clocked. This is called latch. So this is called flip-flop. Especially we will call it as SR flip-flop because its fixed inputs are there, S and R. S stands for set, R stands for reset. SR flip-flop. Clear? Is that clear or not? This is the logic diagram of your
Yes.
SR flip-flop. Okay, now logic diagram is fine, but we should know how to analyze this also. Right. So now, since we have already the information regarding how a latch works, maybe that particular stuff can be utilized now. Okay, but it will be a little bit different when compared to the latch. Why? Because we have clock signal also, right, which is always high. We presume that it is always high, right? And afterwards, we will take T incident and analyze what can be T plus 1. Please try to understand. I know what is the T incident and what will be the T plus 1. That means the table of analyzation of this, which is called characteristic table, will take a format of Q of T, yes, R, and from there, what is Q of T plus 1, we will try to analyze. Please try to understand. Q of T means what? T I know means earlier, and T plus 1 is what I should analyze. Next will what? After going through all the process, what will be T plus 1? Did you understand T and T plus 1? What is the difference? T means past. Past I will presume or I will know. T plus 1 means future I will predict. Is that clear? Is that clear or not?
Yes.
Right. So now, in order to analyze this,
The right
let's
side part of the whiteboard is not. We are.
Yes, ma'am. Can you please shift the camera to the right?
Which one? Okay. Right?
Yes, ma'am.
Okay. Right. So past we don't know. Sorry, past we know, we will predict future. This is what we will tell. Okay. Now, what is Q of T? Q of T means what? The Q's output at the past, T incidents. And what is Q of T plus 1? What is going to be next? Is that correct?
Yes, ma'am.
Okay.
Yes, ma'am.
Now you can ask me, what about Q bar? What about Q bar? That we don't know because we already know Q is and Q bar both are complement with each other. That's why Q bar is not shown in your table. So this is called characteristic table of the flip-flop. This is called characteristic table. Please try to understand. It is called characteristic table. Right? Now let us start. See, don't interrupt me. I will first complete, then afterwards you ask the question. Okay, so first incident is I will take 0, 0, 0. Now this is just an assumption. Okay, that means I already know there is T incident. What is T plus 1? I will write outside the box. Okay, in green I will write. Okay, so in black I am using the current situation. You also use pencils and all. So S is 0. Right? R is 0. Already I know. This is 1. Is that correct? This is what the setup as per that row. Q of T means I know already what is past. This is presumption. Presuming that Q of T is 0. Right? S is 0. R is 1. Is that correct? Now my task is what comes here. Means next, what will come here after doing the process? This is what it comes, right? Now hold on. Now Q bar I am not showing there, but we can get here. Okay, if you want, you can show in your table, right? So now tell me, after this, now I will write what will happen here first. So what is here? Clock is 1. This is 0. This will be 0. Is that correct? Is that correct or not?
Yes, ma'am.
Okay. So that means this 0 travels here. That means this is the same signal. Now this blue color is a box only. Please try to understand. Okay, this is only box. Okay, just to tell that this is a latch. It's only a box. Okay, it's not interrupting anything. It's just a box. Okay? Right. So 0 travels here. Now, this 0 is there. Already it's there. So it is this one. And what will be here? 0 is here. Then what will be next one? See, if this is 0, it is automatically 1. Because previous one. Is that correct or not?
Yes, ma'am.
So now we can, so this is 1. So afterwards here 0 comes, and if this one reacts, what will be the next one? Here, what will be here? It is 1, no?
Yes, ma'am.
Ma'am,
How it is
0.
1, huh? 0!
0, 1, output 0.
Yeah, it will be 0. It will be 0. Please try to understand. I just confused you purposely. Okay, please try to understand. This the green one is the prediction one. Okay, black one is the existing one. See, these one is already known. Okay, so here this is, if this is 0, q of t, q bar of t is 1 already. So that means if the signal comes also, doesn't matter, this one will be existing and this one will react also, and output is 0. Yes or no? Is that correct? That's all. Okay. So now let's take the next one. Okay. So next issue we will have to remove. This is how we will do. In the class also, everybody does like this. I will change. Okay. Only one thing will not change, is clock is always high. Okay. Now next is I want this. Okay. That means Q of t is already 0. Right? S is 0. R is 1. Okay. Yes or no? This is what given. Now what will be Q? What will be Q? What will be Q means what? Q of t is 1. What will be Q of t plus 1? That is what the prediction. So how you will analyze this? This 1 and this 1. Here 1 comes, here 0 comes. Is that correct? Yes,
Yes,
or no?
ma'am.
Yes,
Okay.
ma'am.
So now 1 and 0, irrespective of whatever flows here, output of Q of t plus 1. I am catching here. How much it is?
1.
0.
Zero.
Zero.
If
Zero,
if
zero.
any of the input is correct, yes or not?
Yes, ma'am.
Yes, ma'am.
Now
Yes, ma'am.
next one, 0, 1, 0. Let's start. See, it will be a little boring at starting wise. Okay, let's 0, which is 1.
1.
Yes, S is 1. R is 0. Right. Now let's start. What is this? This is already 0. Right. So now who will come here? Here 0 comes. Here 1 comes. Now tell me.
Is it 1? Is it 1?
1.
See, I have only
Answer.
2 options. Is it 1 means what? You should
Ma'am,
be
answer is 1.
concluding.
Answer 1.
Ma'am,
Answer
1.
Answer 1. But you
1.
should tell me how.
Ma'am, it is 0 Q dash. Then it will go to up to the gate number 1.
So
So
this is
2
already
zeros
1.
to
So
answer
this
of
is,
1.
it will be 0. So already it will go. This will 2 are low. Then output is 1. Perfect. Good. Very good. Good. Okay. Now next. Oh, sorry. This is yeah. Yes.
0.
Zero.
Ma'am,
I
don't
will-
care, man. Not one.
I will kill you guys. Only one fellow is so good. Don't care. Yes, Shweta? No answer. Girls, why no answer? Just see how they are behaving. This clock allowed both ones here. What does it mean? Even though there is 0, these two NOR gates will react. Now, 1 means outputs are zeros. So, how come a Q of T plus 1 and Q bar of T plus 1 are having two zeros? Impossible. It's a don't care. Indeterminate state. Yes or not? How much I told you for the latch? Please try to understand. Is that correct? Because just see, 1 appeared at the latch, right? We don't know what is here. You may do that like, okay, 0 comes here, then it flows here, then it flows here, then it comes. No. When two inputs are 1, this NOR gate reacts immediately. Irrespective of any of the past inputs, but the fresh input is 1, so output should be 0. Next is immediately determined. It goes to indeterminate state. Only one has given a good answer. Correct. Very good. Do you agree for this?
Yes, ma'am.
Yes, ma'am.
Yes. Hold on. So now next one. 1 0 0. Quick. Now you start. 1 0 0. That means here it's 1 0 over 0. Now test. See, 0 travels here, 0 travels here. That much I can tell.
It will be 1.
1.
Yes, this one is
One.
there already. So output is Q of T, Q bar of T plus 1 is ready. That is what? It is 0. So 0 over 0. The next will be 1. Yes or not?
Yes, ma'am.
Yes, ma'am.
Okay. Now continue. So 1 0 1. 1 1 0. Please tell me for 1 0 1 and 1 1 0.
0. 1 0 1 0 1 1 0 1.
Okay. So this is 0. This is 1. So 1 1 1. What about this?
Don't care, ma'am.
That's it. Same thing. See, irrespective of that, 2 1s are coming here. Output will be don't care. Now, this one is the characteristic table of such type of arrangement, which we will call it as SR flip-flop. Now, please try to analyze and understand. This is the starting building block. Okay, if you don't understand to analyze or estimate what is going to be next, okay, using the circuit, then everything will be like what? Sequential will be very boring. If you have doubts, please now itself you clarify. See, I followed a particular task. This is the established flip-flop. That's why I'm explaining. We can create our own flip-flops. Don't worry, that I will make you do. Okay, so but are you able to understand what exactly already established? This is flip-flop logic diagram. That is called characteristic table. Is that correct? Characteristic table. Now tell me what will be Q of T plus 1? This is called characteristic equation. Q of T plus 1. Can you just do a K-map and then give me what is Q of T plus 1 means? Characteristic, use the data, don't care also. How much it is? Is it coming how much? S plus? Is that correct? Is this much only coming? Please check out characteristic equation. This much. This is called characteristic equation. How this much only coming? This is the simplified?
Yes, ma'am.
This much.
Yes, ma'am.
Okay. Now this is called as logical symbol. Logic symbol. This is logic diagram, logic symbol. What does it have? Two inputs S and R. You have a triangle here to tell that is clock. Okay, this is called clock high. If at all you have a bubble like this, it is called clock low. But here we have used clock high. This is clock. Okay, with a triangle. Q and Q bar. Right. Yes, opposite is Q. Why? Because S is coupled with Q. Yes, R opposite is Q bar. R is coupled with Q bar. That's why it is shown crisscross inside. This is called logic symbol. So this is your history of your SR flip-flop. Is that clear? Is that clear or not? Now, if you have any doubts, now itself you tell. Because see, it's a NOR latch. Okay, now you should be thinking that they can be a NAND latch also. I will not confuse you teaching NAND today. Okay, only keep NOR latch into, your brain. What is that? If at all any of the input is 1, okay, NOR reacts. Output is irrespective of the other input, it makes 0. Right? So this is what the building block of this particular flip-flop. Please try to understand. Is this clear? Everyone. Because tomorrow class you should be familiar or acquainted with this type of arrangement. Now you can ask me, ma'am, can we change this one? Yes, you can very well change. You can make the clock 0 and design your own circuit. Instead of NOR latches, you can use NAND latches also. That comes later. First you master what is existing. Please try to understand here. You should be very quick in understanding why it comes as a NOT. NOT means cross here at this. Because 2 of the inputs are coming 1. That's all. Right. This is what you have to question yourself and get the answer. Yes, class? Today's class is a little what? Confusing? No. Or okay? You still have to understand.
Excuse me, ma'am.
Yes, ma'am. Go ahead.
Ma'am, the latch, those two NOR gates, do they work together or there is some delay? It's one high one
yes.
works first, then lower one.
Yes. Now we are talking about latch or flip-flop.
Only latch.
Okay, only latch, there will be a delay. Definitely. Now you cannot measure that delay. Neither, see, its output is glowing. It is a blink only. Na? Your human eye has to track whether the 2 outputs are coming at the same incident. Is that correct? So they will definitely two NOS definitely have a delay because they are not of same make. Though whatever we take also as two people never matches, the same thing will be there in the gates also. They both will be working with a delay in that. Definitely 100%. I do agree. Yes, ma'am. Anything else? Only one question.
Also, it will be there.
No. Why? I'll tell you why. Because you see, these signals are entering here, no? Who are entering here? These wires are being controlled by the clock. That is how the network will be. This clock will control the entry of the signals. That's why we will call a clock is a gateway. Right. It will allow the signal when the clock is automated as high. That's all. When this is high only, it will enter. Otherwise, no entry. So the flip-flop is a better than the latch. The delay can be further reduced. I cannot say delay 0, but I can say it is reduced high. Very big reduction. Is that fine?
Yes, ma'am.
Yes, ma'am.
Yes. Clock flip-flop is this. Now, right now. Okay, now I will have a small question for you. If I want to have a NAND logic instead of a NOR latch, what should be my idea? I'll just erase it and 5 more minutes are there. I can discuss on that. If I want to have a NAND.
If any one of the input is 0, then we can say the output will be 1.
Yes, so that means that's the basis of the NAND. Correct. If any of the input is high, the output is checked out. So I can easily say if I use a NAND logic, Gate 1, gate 2. Right? Gate 1, gate 2 NAND, if at all I use and try to analyze. Okay, so what will, so I will have Q and Q bar as usual. Should I use that? Same thing? Same level I will use. Gate 1 and gate 2, Q and Q bar. I will have some X and Y. Okay, so now logic you tell. If any means just our latch, XY latch I am telling. Okay, so how the logic will be? I will have X and Y changing, then Q and Q bar. Right. So as per somebody has told, what is that? If any of the input is 0, the output is high. Correct or not?
Yes, ma'am.
Okay. So now my X and Y is there. So let me start with what will be the output. What will be my output? Q and Q bar. See, X is 0 or Y is 1. So 2 gate will be what? If any of the input, immediately this is 1. No?
1.
Yeah. So Q bar is 1, which leads to the, oh, I'm so sorry. Hey, you people didn't tell me? Okay. You didn't correct me. I have connected here. I have to connect to the 2 inputs. No? Oh, okay. So X is 0, Y is 1. Okay, X is 0, Y is 1. This is what the initial experiment. So this is 0 means this is reacting is first one. So 1. So 1 and 1. What will be output? 1 and 1. Correct or not? No?
Yes. Yes.
Yes. Right. So after this, I will retain this one. This particular one, I will change it to 0. Now tell.
Ma'am,
Tell.
both
What will
will
be the
produce.
output?
Ma'am, it won't work. Like
Yes, ma'am.
both will
Don't work.
produce 1.
Why?
Both will produce 1,
Yes.
which is
So
contradictory.
what will both will produce 1? So this is a wrong thing. No? Both are complement to each other. So that's what. Even in the NAND also it suffers the same thing. Though the inputs might be different, but it suffers. Yes or not? Yes or no? Right? So question comes, even if you use a NAND latch or even if you use a NOR latch, for a particular set of inputs, their reactions are indeterminate. That is what I want to prove. That is point number 1. Point number 2 is, let us organize that and then use a clocked version of this and just check the characteristic table of that flip-flop. Then also we will have some indeterminate situation for this particular setup. We have to do some more clarifications and some more workout on this one, because we are getting some indeterminate states. Is that clear? Okay. Now, for example, I have 1 1. I'll start a second trial. 1 1. So what will be 1 1 means? What will be 1 1? How the reaction is? If I start with both high, can it react? How it will react? Tell me.
Yes, condition.
Yes? Can it react? Both are high. Hello?
Ma'am, just memory storage, I think.
It won't react also. Whatever we will get, we will have some blink, but it is a wrong one. Because this 1 1 situation means what is happening, this particular type of arrangement, it should be always have a set and reset mode. That means if one signal is high, other should be low, then only the reaction continues. Did you observe that pattern even in the previous one? Both high at a starting itself, it will dissolve, because it is not able to react also. Now both high, how it will react? without knowing what is existing here. Is that correct?
Yes.
It has to come from a previous incident. Maybe prior to this it might be like this. So it is retaining like this and this one has changed. That time it can help. Right?
Ma'am, we have HS.
You have?
HS class.
Go. Seven.